Greetings and welcome, friends. Mr. Waddy here. We are talking about section 3.5, which, just to let you know, my internet friends, we're going to cover in two parts. That's when you take one thing and break it into two things. So, if you want to see how to do division by two, check out my friend Sal Khan, khanacademy.org. He'll help you out with dividing things. But right now, we're talking about, I don't know, like lines, exploring lines, parallel and perpendicular in a coordinate plane. I think that's like 90% of the title of this section. But let's check this out. Here we go. Partitioning a directed line segment. What is going on? What? Directed line segment? Man, I haven't talked about a DLS ever. Directed line segment. Here, let's find out what it is together. A directed line segment, AB, is a segment. Okay. You're with me. That represents, this is the part that makes it directed, moving from point A to point B. All right, so the only thing that's different is that you're pretending that there's at one time, right, at different times, you're moving along this path in that direction. That's probably something, I don't know. But yeah, there we go. That's a directed line segment. It looks just like a regular line segment. We're just using it to represent motion and time and displacement and distance, location, just words, really. Let's see. It says the following example shows how to use slope to find a point on a directed line segment. Okay. All right. So, that partitions the segment in a given ratio. So it says the following. Find the coordinates of point P along the directed line segment so that AB, let's see, along the, let's see, now I'm just signing my name here. You know how it is, YouTube fans. I'm always getting asked for my autograph because I'm so internet famous. So let's see, find the coordinates of point P along the directed line segment AB so that the ratio of AP to PB is 3:2. Okay? Are you with me? So let's see, in order to divide the segment in the ratio 3:2, think of dividing or partitioning the segment into 3 plus 2 congruent pieces. All right, so I'm going to imagine, I don't know, I'm not going to do this very well, but imagine dividing this up into 3 plus 2 congruent pieces. So 3 plus 2 is 5. Did I divide it up into 5? 1, 2, 3, 4. Nope. I failed, friends. Well, there we go. Let's see. I could have just midpointed it, right? And then, did I do it wrong again? I did it wrong again? Wait a minute. 1, 2, 3, 4, 5. All right. Use your imagination, friends. I'm not going to draw this part of the sketch. Good stuff. Okay. So 5 congruent segments. All right. You guys are imagining far better than I was able to actually partition it. Let's see. Now I'm going to find the rise over run from point A to point B. So in terms of slope, this is going up by how much? How many boxes is that going up? Yeah. Let's see. For my rise, I'm sorry, I'm going from A to B. You were looking at, I think, this, right? Maybe. But if I do the y coordinate minus the y coordinate, I get 6 is the rise. And what's my run? 3. I would subtract the x coordinates. I'd get 6 minus 3 is equal to 3 for my run. So the slope of AB is equal to, actually, do you guys even know the slope formula yet? Yeah. Do you remember the slope formula?
You said it, I probably remember.
M is equal to y2 minus y1 over x2 minus x1. Okay, and in this one, the order matters. Once you've selected one of your points to be point 1 or point 2, you have to commit. Because if I swap this to like x1 minus x2, my sign is going to be off. All right, so if I found the slope, I just did kind of rise over run right here, but notice what I actually ended up doing was the slope formula. 8 minus 2 over 6 minus 3 is equal to 6/3 is my rise over run. Now, I know I could also reduce that to 2, and actually, does that make sense? Up 2 over 1, that does in fact land on another lattice point. Up 2 over 1, up 2 over 1. Right? Good stuff? Let's see. So now let's see. We want to find the coordinates of point P, add 3/5 of the run to the x coordinates. Okay, let's see. What's the run? All right, the run is this guy, and the rise is this guy. Are you with me? Rise and run. Okay, so I want to add 3/5 of the run, and I'm going to move that far over. So let's see if I can do that. So 3/5 multiplied by the run, 3, is going to be 9/5, okay, which is equal to 1.8. So I would move over 1.8 spaces this way, okay? And then I'm going to find 3/5 of the rise. The rise. Let's see. So 3/5 multiplied by the rise, which was 6. You guys tracking this? 3 times 6 is 18/5, which reduces to 3.6. So I'm going to go up. Watch this. 1, 2, 3, and 0.6, somewhere around there. Okay? So we're finding, all right, remember what we're doing here. We're finding point P along this directed line segment that is 3/5 of the way between those 2 points. That's what, well, because it was a 3-to-2 ratio, so 3/5 do the part divided by the total. What percent of the way is it there? It's 3/5 of the way there, or 60% of the way there.
Why? How would this useful?
Well, this would be useful in, I'm assuming, vectors and probably, I don't know, probably physics, I'm guessing, particle motion. There is eventually, later on, I don't know if they covered in pre-calculus here, but parametric motion, which is kind of what this is describing, where it's a point moving along a path at a particular time. But we're almost done. Let's just finish this example so we can get to the better ones. Question? Yeah. Because 3 plus 2 was equal to 5. So if the ratio was 3-to-2, I want to be 3 out of 3, right? 3 this way and 2 that way, but that's a total distance of 5. So that's what we were doing. So I found 60% of the rise and 60% of the run, and those would give me my new coordinates. What are the coordinates of point P? I'm running out of colors here. What's a good color? I've already used, I don't know, dark blue, I guess.
Orange, green, blue, purple.
Let's see, so P is going to be the point. Yeah, that doesn't show up well enough. Let's see, maybe, I don't know, this weird fuchsia. I don't know color names. Well, let's see, P is going to be 1.8 added to the x coordinate here. So that's what, 4.8?
Yes.
4.8, and 3.6 added to the y coordinate, so that's going to be 5.6. So P was 4.8, comma 5.6. Yeah, I've never, I don't think I've ever seen this show up in a geometry book before, so I'm interested to see what we'll end up doing with it. But there we go. That's what we were asked to do, and that's what we did, right? So I added. To find this, I did 3 plus 1.8, and to find that, I did 2 plus 3.6. Right? Okay. So let's get actually to these other more interesting questions, I think. Let's talk about some theorems. Theorems. Actually, you guys probably already know these ones. I'm guessing. Let's see, I'll fit these on one page. Bam. Theorems. Here we go. Yummy, delicious theorems. Theorem 3.13, that number is arbitrary and is only related to this book. Slopes of parallel lines theorem. In a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. All right, so M1 is going to equal, I thought I was being clever and then I realized they wrote the same thing there. Right, they have to have the same sloppy slope, right? And then they also have this additional statement, any two vertical lines are parallel. What are the slopes of vertical lines? It's no slope. It's actually, you could think about it as going up infinity and over zero for a vertical line. What's the rise? Go up forever and then don't go over at all. And infinity divided by zero, we just call that no slope. All right, so no slope for vertical lines. That's why they had to distinguish it from the rest. That's why they did that. So two lines are parallel if they have the same slope. Also, they have to be distinct lines. We wouldn't call coincident lines parallel because parallel lines never intersect, whereas coincident lines can never not intersect. They're just the same line all the time. Okay, so let's see, here we go. Slopes of perpendicular lines. I don't know if you guys know this one. They're wording this funny. Let's see, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. I'll also make this note, Alyssa, which I know your friend is telling you right now as well, that their slopes are opposite reciprocals. Did you guys know that one?
That seems kind of redundant.
What does, well, reciprocal, I like to sometimes say refliprical. Oh, man. Okay, so let's see. If M1 was equal to, say, A over B, then a perpendicular line would have a slope that is -B over A. So the reciprocal part is flipping it. The oppositing part is changing the sign. Okay? In their case, they said the product of their slopes is -1, which also applies. So if I have, say, a slope of 2/3, and I multiply that by a slope of -3/2, it's opposite reciprocal. Watch this. Get ready. This is going to be brutal. 2 and 2 kill each other in a knife fight. 3 uses the battle rifle on that one, but then also this guy stuck him with a plasma grenade at the same time. Oh, man. Everyone's dead. Oh, it's just -1.
Why?
Well, there's the minus sign was still there, and then, like, yeah, they all reduce, but it's 1, yeah. So, but opposite reciprocals is the idea. I find that easier. When what?
When whatever is multiplied by opposite, it's always equal to -1.
That yes. Well, or think about it this way: if I did 2/3 multiplied by 3/2, ignoring the minus sign, that would have been 6 over 6, and anything divided by itself is equal to 1. In case you don't like the everything cancel out part, and then just throw a minus sign in there, and everybody's happy, right? Yeah, but -1's just like kind of like like you're like, oh man. So everyone that's remaining is happy, but kind of malicious, I guess. Yeah, I don't know. So let's take a look at this one. Oh man, we might just do some of these, or maybe we'll only test the ones that we're suspicious of.
This is easy.
Okay, here we go. It says, determine which of the lines are parallel and which of the lines are perpendicular. Oh, guys, wait a minute. Can I steal the color? Did it? No. Oh man, my inkwell tool isn't working here. Oh, there it is. No.
Oh, you got it. Yeah.
That's weird. Whoa, look at that. That is weird. Where's the white even hiding? What? What?
Oh, no, probably. What?
I don't even know what's happening. But either way, I'll just try to work with those colors. Guys, let's find the slope of... Oh, dear. What did I do? Let's find the slope of the orange line. I'll call it M1. What's it doing? It's going up 1 over 3, slope of 1/3. That was like a triple 3 right there. Let's find the slope of this blue line. I'll call that slope 2. Looks like it's going from lattice point to lattice point up 1 over 2, so that's a slope of a half. Rise over run. You know what I'm saying? Let's go for fuchsia here. Between those lattice points, what's the slope? Up 1 over 2. All right, so slope 3 is a 1/2. And let's find the slope of, looks like a light green, a limeish green. I don't know, we'll call that slope 4.
Also.
Let's see, where's another lattice point for this line? Oh, right up here. Yeah. Actually, I think I did a pretty good job color selecting that. I'm pretty close. I think I'm within like 3% of the color, right? So it looks like, what would the slope between these 2 points be? Down 2 over 1. So that's negative 2 over 1 or just negative 2. Okay, so question for parallel. Man, I've got to get the more vibrant color here. Parallel, which lines are parallel?
3.
2 and 3. Okay, and how about perpendicular?
Oh, 4.
Nope.
4?
2 and 4. Sorry, and 3 and 4, right?
Yeah, okay.
Oh, you're right. Oh, wow. You're so good. I didn't even notice they had names. But just like you guys, I don't really know your names either. So it's all right. You're just a bunch of backs of people's heads to me, and I just teach geometry. But yeah, so 2 and 4, are these opposite reciprocals here?
Yeah.
Yeah, flip a half, you get 2 over 1, and then opposite it. Perfect.
Look at that.
And the same thing, would you just look at it? Would you look at it, though? Would you look at it? And also, if I multiply these, that's equal to negative 1. So yeah, these two are perpendicular, and so are those two. I could have, just in case you wanted to see, ooh, look at this. All right, you also could have done a whole bunch of work, but in our case, I was just comfortable doing rise over run. But you could have done slope formula, you know, that sloppy formula, and found the slopes of each of those independently and done that. Oh, here we go. Here's what I really wanted to get to, friends. Last example of the day. Maybe I'll do 2 of them, though. Who knows? All right. Oh, boy. Boss fight. All right. Write an equation of the line passing through a particular point that is parallel to the line y equals 2x minus 3. Oh, man. Oh, man. This is going to be awesome. So, all right. What is the slope of this line? 2, all right? So what is the slope of my line going to be? Also 2, because my line is parallel. So I want to have the same slope. So, okay, so far, this is what we've got. So in the equation, y equals mx plus b. I know that y is like starting to evolve into a g, but I'll just hit B button and cancel the evolution. So let's see, y equals mx plus b. I just found m, right? Okay, I just found m. Cha-ching, m. We're good. The only other piece of information I need for my line is to find b. I've got to find b, right? That's the remaining piece of DNA that makes a line unique. And how can I find b? Well, I don't know b yet. Is this the y-intercept? No, that's not the y-intercept. Man. Oh, man. Right, so I found m. I got to find the y-intercept. What I do have, though, is a particular ordered pair. Let's see, I'll label this purple, I guess. x1, y1. This is an ordered pair that I could plug in for x and y. And if this point is on the line, okay, all right, if it passes through that point, if it's on my line, then that means if I was to plug this into my y equals mx plus b, that it would make the equation true. All right, all points on the line, when I plug their coordinates into the line's equation, will make the equation true. So ready? This is what we're going to do. I'm going to plug in these points for my x and y. I just pointed at y first and then x. I'm going to plug those points in for x and y. I'm going to plug in 2 for m. All right, so let's see. Watch what we got. 1 is equal to, bless you, 2 for m, -1 for x. And I don't yet know what b is, but check this out, friends. I plugged in what I know, and I solve for what I know. Classic algebra. Man, it's our favorite. So let's see. Let's solve this equation for b, and I'll find the missing piece of dino DNA. So let's see. 1 is equal to 2 times -1 is -2 plus b. How do I solve for b? What do I do to both sides? Add 2 to both sides. Oh, no, you didn't. I get b equals 3. Guys, we found the missing piece of DNA. Right? Right? So I've got m, I've got b. Do not, by the way, oh, this is so funny. Sometimes students will they'll be solving this problem, and they'll just be like, b is equal to 3. I'm like, that's not what we asked. We asked for the equation of the line, my friend. So what is the equation of the line? Yeah, let's see. Let's simultaneously, everybody on 3. No, that would actually be really difficult. Y equals what?
X plus 3.
Wow, I really, you guys were almost so synchronized. I wish, when I came to class, I'd be like, good afternoon, class. And then you'd all be like, good afternoon, Mr. Waddy. That was almost how synchronized you were. That's my dream as a teacher one day.
Is it really that?
No, actually, not at all.
What is your
No, I don't know. I was just thinking of, what is my dream as a teacher? Wow. I don't know. I should make another video about that. I feel like that's a deep question. That's a deep question there, friend. Let's see. All right. Let's see. Let's do half of this because I feel like this is weird. Okay. Actually, to summarize what we did, we found the slope of the line they gave us, and because ours was parallel, we had the same slope. We then plugged that slope into y equals mx plus b, and the coordinates of the point that I had for the y and x, respectively. I solved for b, and then I took my 2 pieces of dino DNA and reconstructed a dinosaur. All right, that's what we did. All right, so let's I don't want to just have only one example of that, so let's do this one as well. We're just going to do part A of this one. Okay. I think you guys have this on your sheet. I might be wrong. It says, write an equation of the line that passes through the point and is parallel to the line y equals 3x minus 5. Okay, if not, just follow along and enjoy. This is going to be awesome. Okay, so if it's parallel to this line, I don't care about that y-intercept. I don't care. That's their y-intercept. I want my own y-intercept, right? You can't tell me what to do. I don't want your y-intercept anyway. I'm happy without it. I'm going to get my own y-intercept. But what I do need is some starter money from you, Dad. Just give me $1 million loan. That'd be cool. Just a small loan of $1 million so I can start a business. So let's see. Here we go. The slope for their line is 3. What is our slope going to be? 3. And then I forget them, right? I don't care about that line anymore. I'm going to go start my own line. So m, my slope is equal to 3. What else do I know? I know that this is a point that's going to make my equation true. So I'm going to plug this in as one of the x and one of the y coordinates that make the equation true. And I'm going to plug them into y equals mx plus b. I'm going to plug in what I know and solve for what I don't. This is going to be awesome. So let's see, y1, we'll plug in 5, is going to equal 3 for m, 1 for x, plus b. Plug in what I know and solve for what I don't know. And let's see, what do I do to both sides?
Subtract 3.
Yeah, subtract 3 both sides. I'm going to flip it using symmetric property of equality, 5 minus 3, b equals 2. So the equation of the line perpendicular to this one that passes through that point has this as its slope, this as its y-intercept, and the equation is y equals what? 3x plus 2. That's not like the same. Was that the same one we just had? I feel like that's similar.
2x plus 3. It was 2x.
All right. Yeah, not the most creative numbers, but you tried, book. You tried. Let's see. Just as a hypothetical, we'll talk about this tomorrow. But if I was to consider part B, what is M2 in part B?
What?
Oh, how so? Why do we know? It's not just the reciprocal. It's the opposite reciprocal, right? So the slope of that line was 3. So the slope of a perpendicular line, actually I shouldn't underline perpendicular, I should do it this way, would be negative 1/3. Flip it and opposite it. All right, well, thank you so much, my friends, for watching. Man, that directed line segment one, though, ugh. You might just want to, like, skip the first 5 minutes of this video. I don't know. Have a great day, friends. Bye-bye.